Given the height of the rocket by the position equation, we're going to find the average velocity for the rocket from time is equal to 4 to time is equal to 5. So we have to use the change in position over the change in time, using the values time is equal to 5 and time is equal to 4. So the position at 5, substituting 5 into the position equation, get the value of 108. Then find the position at 4 by substituting 4 into the position equation. You get the value of 136. So the position at 5, take away the position at 4, over the time 5 minus 4 makes the answer of negative 128. Now we'll do the instantaneous velocity. The instantaneous velocity is the derivative of position. So the derivative of position is 80 minus 24t. So velocity at 4, replacing 4 into the derivative of position, get the answer of negative 16. To figure out the highest point that a rocket reaches, imagine the position equation. The highest point is located where the slope of the tangent line is equal to 0. So we need the slope of the tangent line of our position equation and set that equal to 0. The derivative of position then set equal to 0. So we'll take that 80 minus 24t, the derivative of position, set that equal to 0, and that's time is equal to 10/3. Now to find out how high that rocket traveled, when time is equal to 10/3, replacing 10/3 into the position equation will get our position of that rocket at time is equal to 10/3. Which gives an answer of 424 over 3. Then to get to acceleration, acceleration is the derivative of the velocity. Previously we got the velocity equation, so we'll take the derivative of velocity. The velocity equation was 80 minus 24t, so derivative of velocity is negative 24. That's the acceleration, and now we get the acceleration at 4. Still the answer of negative 24. Given the graph of the salesman's distance from home given time t, we're going to find the average speed. Average speed is the absolute value of the average velocity. So finding the locations of the average velocity, change in distance over change in time, taking the absolute value of that answer, so 60 minus 10 over 10 minus 9. So we'll get 60, numerator is measured in miles, denominator in hours, so 60 miles per hour. Part B, we're doing the same thing, average velocity, absolute value of the average velocity, this time looking at the time is equal to 3 p.m. and 4 p.m. So we have 120 minus 60 over the 3 p.m. minus the 4 p.m. Absolute value of our answer, speed is the absolute value of velocity. So again, we get the time travel of 60 miles per hour. So now the salesman is clocked and pulled over by a policeman at 3:30 p.m. This is an instantaneous speed. So this is a speed at an instant in time. Since we're talking about instantaneous speed, we're thinking about the slope of the tangent line of the graph. So if we sketch an approximate slope of our tangent line to the graph at 3:30 p.m., we can estimate what the slope of that tangent line is going to be based upon the tangent line that we drew in the graph. And using 2 points that fall on that line, looks like approximately 80 minus 40 over from 3:30 until 4 o'clock. From 3:30 to 4 o'clock is a half hour. So we have in the numerator 40 divided by the half hour in the denominator, which makes 80 miles per hour. Next problem we're going to look at numerically. We're going to find the average velocity over the first 263 feet. So using 263 and 0, and then the time that corresponds, which is 3.6, and time of 0. So we get 263 over 3.6, which calculates out to 73.056. The numerator is being measured in feet, and the denominator is being measured in seconds, so feet per second for our units. Do the same kind of problem for the next. Finding the average velocity, this time using time is equal to 2.8 and time is equal to 1.2. So finding that information in the table, we use the change in distance, which is 246 minus 146, over the change in time, which is 2.8 over minus 1.2. This calculates out to 62.5. Again, the numerator is being measured in feet, and the denominator is measured in seconds. So our units are in feet per second.